In the same way, deletion also it can be performed beginning and as well as or a particular position. P assigns start. Whatever node in the P, that will take the address of start node. Whatever address we have, that address here we have to connect to the starter point. Welcome back to one and all. Myself, Vasanta, lecturer in Computer Science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysuru. Today, we are going to start with the last session of Data Structure chapter. That is the 10th session of Data Structure chapter. Whereas already in the previous session, you come to know regarding the algorithm for insertion, that is nothing but NQ operation, algorithm for deletion, that is DQ operation, then application of queues, linked list, then which are the operations on a linked list we can able to perform. With that, creating a linked list, then the new as well as delete operators, what is the main use of new and delete operator, then algorithm for traversing a linked list as well as memory allocation to a linked list. Whereas today you will come to know regarding algorithm for inserting a node at the beginning of the linked list. In the beginning, how to create a new node, how to link that, then algorithm for inserting a node at the end of the linked list, at the end how to insert a new node, then algorithm for deletion of the first node. If I want to perform delete a node, then in the 3 position I can able to delete, that is in the beginning or at the end or a particular position. In the same way, deletion also it can be performed beginning and as well as or a particular position. Here also algorithm for deleting at the end of the node. Then what do you mean by nonlinear data structure? Tree, binary tree as well as graph. Regarding that, you will come to know on today's session. First, we'll discuss about algorithm for inserting a node at the beginning of the linked list. In the beginning, if I want to insert a node, then first what you have to do, consider you have the linked list. Here the start contains the first node address and here the first node contains, for example, the value A, and in the address part it contains the next node address, for example B. Then here I am having null. If I want to insert an element at the beginning, first what I have to do? First I have to create one node by using new operator. Then here you have to insert the value, whichever value you want you can insert. Then for the address part, here you have to write the previous, whatever previous node we have, that is the first node, that address we have to write. Whatever address in the start, that we have to connect here. There first, in the first step, P assigns new node. We have to create one node first by using new operator. Then in step 2, we have to add num to the data part of that node. We have to add the value here, number, to that new node. Later on, whatever address in the start, that we will connect to the link part. In the previous node, whatever address in the starter node we have, that we have to connect to the previous node. Then P assigns start. Whatever node in the P, that we will take the address of start node. Then return. This is the step to create a node in the beginning in a linked list. Now is it clear? Next, we will explain regarding the algorithm for inserting a node at the end of the linked list. Consider you have the linked list, start. This start contains the address of first node, for example here A, and then it contains the address of next node, B, and then null. At the end, if I want to insert a node, first step we have to move until we will get a null node. First node will process, second node one by one until we will get the address part is null. Till that we have to move. Then later on, after that you have to create a new node. Because now we are inserting a node at the end. That's why first you have to start from starter point until the address part we are going to get null. Till that we have to process. Once we are get the null address, then you have to create the node, and here you have to give the value, and then for address part you have to write null, then whatever address in the previous node we have, that we have to connect here. It means that if I want to insert a node at the end, first step start. In second step we have start assigns P, that is P contains the first node address. Then while P is not equals to null, while P is till I am going to get null, till that I have to process. Then whatever address on that P, that I will move to next node, then end of while loop. Until I am going to get null, till that I have to process here. Once if I reach the last node, by using new operator, we have to create a new node. Then add the item to the data part of that new node. Give the value there. Insert the number there. Then afterwards, assign null for the link part. Assign null to the link part of the new node. Then new node assigns the link of the previous node. Then take down the previous node address. This is the algorithm for inserting a node at the end of the linked list. Next, we will move on algorithm for deletion of the first node. You know already, start contains address of first node. Then here it contains the data. Then the address part contains the next value B, and then here null. It means that the first node, if you want to delete, then what you have to do? Step 1, start. In step 2, whatever address in the start, that node I am going to call it as P here. Then print the data part of that P. Before deleting, what is the value in that node? That it has to print first. This is the value. Now we are deleting. This is the value like that it has to mention. Then print the data part of that node. Then afterwards, whatever start address we have, that start address on the link, that we have to remove here. And here whatever address we have, that address here we have to connect to the starter point. Now this is the starter node. First you have to print that, then you have to connect the address, whatever address in that we have to connect to the starter point. Then free the node, delete the node afterwards. Then return. This is the algorithm to delete a node at the beginning of the linked list. Next, we will discuss about algorithm for deleting a node at the end of the linked list. And we have to delete the node. In the same way, the start contains the address of the first node, and then it contains the value in the node A. Then here it contains the address of the next node, for example here B, and then null. Here which node we are deleting? The last node. Last node we have to delete. If I want to delete the last node, in the first step you have to start. Then start contains the address of P2 node. Then here I am going to consider the P2 node. The start contains address of the P2. Now this represents P2 now. Then while P2, the link of the P2 is not equals to null, till that we have to process. Until it will move to the last node, till that it has to process. It has to move to the next node. First node, second node, third node, one by one. Till P is not equals to null, till that it has to be moved P2 to P1. Like that, P2 to P1, all the nodes it has to reach. Then link of P2 to P2 here we have to take, then end of while. Until I will get the last node, till that one by one. First time this is P2, next time the next one is P2, like that until I will reach the last node, till that the processing will take place. Then print the data part of P2. Before deleting, print the value. Whichever value on that last node we have, print that value. Then assign null to P1. Here, this is P2. Now, this is P1. Assign null to P1 node. Then stop processing. Then later on, stop processing. This is the algorithm to delete a node at the end of the linked list. Now, is it clear? It means that on today's class, you come to know how to insert a node at the beginning as well as end. And with that algorithm to delete the node at the beginning as well as end. Next, we will move on non-linear data structure. What you mean by non-linear data structure? Whereas in linear data structure, all the elements are arranged one after the another without any break. When you come on, non-linear data structure is a data structure in which data item is connected to several other data items so that a given data item has the possibility to reach one or more data item. Each data item is called as node. Whereas in linear data structure, all the elements are arranged one after the another without any break. Whereas when they come on non-linear, elements are arranged in random format, in hierarchical format. Then that can be called as non-linear data structure. It is not in continuous format, in discontinuous format. And if I want, I can able to reach from one place to another place, but the position are not in continuous memory location. Example for non-linear data structure is tree as well as graph. Graph as well as tree are the example for non-linear data structure. Next, we will move on. What do you mean by tree as well as graph? When you observe this diagram, here it contains a node, whereas tree is a data structure consisting of node organized as a hierarchical or hierarchy format. What do you mean by that? Random format, all the elements are arranged. If you observe this diagram, here the starting node can be called as parent node. From that, whichever node is arising, that can be called as child node. And for example, this is 1, 2, 3, 4, 5, 6, 7, 8. For 1, the child will be node 2 as well as node 3. For the node 2, the child will be 4, 5 and then 6. For the third node, the child node will be 7 and 8. Then the nodes which does not have any children or child node, that can be called as leaf node. The nodes which does not have any child can be called as leaf node. The starting, the rooter can be called as parent node. Here, the nodes which having parents as well as children can be called as internal node. If you observe 2 and 3, this can be called as internal node because this having parent as well as children. That's why this can be called as internal node. Whereas the leaf node, if you observe 4, 5, 6, 7, 8, this does not have any children. Then that node can be called as leaf node. Now here, whereas tree is a node, collection of nodes I can say, but here it is arranged in hierarchical format. A node is a structure which may contains values. If you observe here, this node contains the values. A node that has children is called as parent node. Here, the node which having children can be called as parent node. A node that do not have any children are called as leaf node. Here, the nodes which does not have any children can be called as leaf node. The height of a node is the number of edges in the longest path from that node to leaf node. In this, we can able to identify the height as well as depth also we can identify. If we come on height of a node is the number of edges. How many edges here? See here, if you observe this can be called as edges. The connection between the nodes can be called as edges. How many edges are there? You have to count the number of edges in the longest path from that node to leaf node. Whereas depth of a node is the number of edges in the path from root to that node. That is nothing but depth of a node. Then the topmost node in the tree is called as root node. Here the topmost, or we used to call it as the parent node, is also called as root node. The internal node is any node of the tree that has child nodes and is not a leaf node. That will become a child, but it is not the leaf node. That can be called as internal node. Now, when they come on binary tree, the name itself suggesting that the trees which having two descendant nodes, then it can be called as binary tree. A node which contains two descendant, it means that if the node contains 2 children, exactly 2 only you have to consider, then it can be called as binary tree. A binary tree is a tree in which each node has at most 2 descendants. If you observe this diagram, here this A having 2 descendants, B having 2 children, C also having 2 children. It means that binary means 2. If the nodes contains 2 descendant or child node, then it can be called as binary tree. In the binary tree, it consists 3 parts. One is root node and left subtree as well as right subtree. Whatever thing in the right side of that node, parent node, that can be called as right subtree, and this is left subtree. Then next, when they come on graph, in the graph, a graph is a set of vertices. Whereas when they come on tree, there we used to say it as a node, whereas here we used to call it as vertices as well as edges. The vertices can be called as node and edges can be called as connection. Here, when they come on graph, there are 2 types. One is directed and one more is undirected. Whereas in directed graph, if there is a direction between the node, then we used to call it as it is a directed graph. When the edge in the graph having a direction is called as directed graph. For example, here consider a node. If there is a direction, then it can be called as directed graph. Okay, then a vertex, that is the end point of an edge, is called as neighbor of the vertex. The first vertex is said to be adjacent to the second one. Then, what do you mean by this complete tree? A complete tree in which each leaf is at the same distance from the root is called as complete tree. For example, if I am going to consider one tree here like this format, then it cannot be called as complete tree. What do you mean by complete tree? All the leaf nodes are at same level. This is also cannot be called as complete tree because here this one, this, for example 1, 2, 3, 4, 5. When they come on leaf node, here 3, 4 and 5 are the leaf node. But this all the leaf nodes are not at the same level. See, 3 is at the first position, 4 and 5 at the second position. Then it cannot be called as complete tree. In complete tree, each leaf node must and should be at the same distance. If you observe here, in this I can able to identify the edges as well as height of a node. Consider here, this is the one node, first node, second, third, 4, 5, 6, 7, 8, 9. Now, here if you observe here, then what is the height as well as the depth of the tree? Here, depth equals 0. From the start only we will observe, that's why depth is 0. Then height, longest path from that node to root node. Here the longest path, how many edges? 1, 2, 3. Then height equals 3 here. Longest path you have to consider. Whereas for this one, the height is 1 as well as depth is also 1. From the root node, only one edge I am getting. From the leaf node also, only one edge we are getting. Whereas for the 7th one, if you observe here, height is 0. This is the last leaf node, that's why height is 0. But depth is 2 here. First node, then second edge, that's why depth is 2 here. If I am going to consider for the 6th node, here the height is 0. This is a leaf node, that's why height is 0. But depth wise, from the root I have to count how many edges are there. Here one edge, 2 edges, that's why depth is 2 here. If I am going to consider this 9th one, height is 0 because the leaf node. Then here if I come to depth, how many nodes are there from that node to leaf node? That is nothing but here from root to that node, how many edges are there? That you have to count. 1, 2, 3. That's why depth is 3. Whereas for this one also depth is 3. 1, 2, 3. But height is 0. If you observe this one, height is 1 here. For the 4th one, height is 0, depth is 2 because from the root, if I come, 2 edges I am getting. Now is it clear? This completes your data structure chapter. Next class, we will meet with you once again with a new chapter. Thank you for all of you.